So we introduced the Nernst equation, and now we are going to say a few words about a concept called activity. You probably learned it from your chemistry or probably more advanced physical chemistry. Activity, sometimes we also call it the thermodynamic activity or chemical activity, and has a symbol of A. It is, remember, unitless. Unlike concentration, activity is always unitless, and it's assumed to be one or unity for pure solid or pure liquid. Okay, if the reaction involves pure solid or pure liquid, the activity for that pure solid or for that pure liquid would be 1. It's also assumed to be 1 for solvents in most solutions because solvents are much more than the solute, and the activity for the solvents is assumed generally to be 1. Okay, for ideal gas mixture, okay, can be one gas or can be gas mixture. The activity for gases species J would be Pj over P0. Pj means the partial pressure for that gas species, while P0 just means the standard pressure can be 1 atmosphere or 1 bar. Okay, for an ideal liquid solution, which means some solute dissolved in a liquid solvent and can be water, and typically if it's ideal, it means it's most likely very dilute. The activity for solute J would be equal to Cj, the concentration in mole per unit volume divided by C0, 1 molar per liter. Okay, Cg over C0, and it will be unitless. It will also be equal to Bj over B0. Bj would be the molality of the solute concentration in the unit of mole per kilogram of solvent, and B0 would be the standard molality, which is 1 mole per kilogram of solvent. So this gives us the result for ideal liquid solution. We can get the activity for the solute easily. And for practical dilute non-ideal, non-ionic solutions. Practical means it's not ideal, which means the activity coefficient may not be 1, and if it's dilute and non-ionic, which means it does not dissociate completely into positive and negative charge ion. For such solutions, the activity of a solute can be defined in different ways, such as if you know the molarity, then the activity for J species based on molarity would be Cj over C0, the concentration of J species divided by standard concentration, standard molarity times activity coefficient. Okay, the activity based on B molality per 1 mole per kilogram of solvent, then the activity would be still be activity coefficient, but in this case with the subscript of B represent molality times a ratio between the molality or mole per kilogram of solvent divided by the B0. Okay, and then we can also define activity for species J from the mole fraction for J, and similarly it will also have its own corresponding activity coefficient, and quite often the middle one based on molality is the most commonly used activity and related activity coefficient that you will encounter. And then for the same species, if we know the species, activity would be the same, regardless of the way to express composition, whether it's molar per liter, molar per kilogram of solvent, or atomic fraction. No matter which way you choose to define the composition and the standard case, the resulting activity would be the same, whether you define it based on molarity, molar per liter, or molality B, molar per kilogram of solvent, or a mole fraction. Okay?